Hi, everybody. Welcome to our webinar today on keeping your cloud-native data safe. We're going to present a common sense guide to Kubernetes, ClickHouse, and security. And I hope show you some kind of interesting tricks to combining all three of those things together. My name is Robert Hodges. I'm CEO of Altinity, and I'm backed up by a bunch of work from the Altinity engineering team who have done the legwork and also developed the software that make all of this stuff possible. So before we go into any further into the webinar, I'd just like to give you a couple of hints that will help you enjoy this more. And so first, this is being recorded. So you will get an email containing a link to the recording as well as the slides that we are presenting should show up within about 24 hours tops of this talk ending. The second thing, there is time for questions. You can enter them into the handy question and answer box or just throw them into the chat. If it's something that's relevant to the talk, I'll dive right in and answer it as we're going along. Otherwise, there'll be a little bit of time at the end and we can cover questions as well. Feel free to ask anything. We're interested in this topic and there's lots of ins and outs, so don't be shy. I think with that, we've got the housekeeping done. I'm going to just go ahead and dive in. So first of all, some introductions. So I'm Robert Hodges, as I said. My day job is I'm CEO of Altinity, so I spend a lot of time looking at spreadsheets and running the business. But I've been working on databases for about 40 years at this point, so it says 30 plus because it doesn't sound so old. I've been working on Kubernetes since 2018, started at VMware, and have been kind of growing with Kubernetes ever since. The Altinity engineering team I mentioned, Altinity is a full service company. We'll talk a little bit about what we do in just a second, but we're about 2/3 of our staff are engineers. That's about 30 people spread out over a wide range of countries. The company covers something like 16 different countries worldwide. Taken together, we have a huge amount of experience with databases and with Kubernetes because we run a cloud based on Kubernetes. In fact, that brings us to what Altinity does. We are an enterprise provider for ClickHouse. We basically enable you to run analytics based on ClickHouse anywhere you need to. Among other things that we do, we have Altinity.cloud, which was the first cloud developed for in the Amazon cloud as well as GCP for ClickHouse. It's been around now for coming up on 3 years. Has many happy customers. We also offer enterprise support. Again, many of our customers run in the cloud on Kubernetes, so these are purely self-managed. We'll talk a little bit about the models that we offer at the end of this talk. And then finally, and this may be one of the reasons why you're listening to this talk, we're the authors of the Altinity Kubernetes Operator for ClickHouse. That's the full title of it, but it's known for short as the ClickHouse Operator, and it basically makes ClickHouse cloud native. So we started work on that about at the beginning of 2019 and have been working on it ever since. So invested a huge amount of effort to get ClickHouse to be fully cloud native. Speaking of Kubernetes and cloud native, I'm going to start this out kind of basic because I don't know what people's level of interest is, but we'll layer this up and build up to something useful pretty fast. So the first question, just to set expectations, is what is Kubernetes? Well, it's a system for orchestrating container-based applications. What that means is if you have an application that can be deployed as one or more containers, say Docker containers, for example, Kubernetes can take those containers and deploy them anywhere you want in any combination you want. It can scale them up, it can scale them down, it can manage storage for you. It's a very capable system for developing modern applications. And a typical example, very simple example, is that you could have a ClickHouse database. So ClickHouse is, as you probably know, a very popular real-time analytic database. It is available in Docker containers from multiple sources, and you can run it on ClickHouse. And so you have the ClickHouse container, which is going to be talking to block storage. So how does Kubernetes do that? Well, what Kubernetes does is it has a model for distributed applications containing these different things that you see across the top, like a stateful set, which is a type of resource that is used to manage, that's handy for using containers that actually have storage that they need to talk to. and it can remember to connect the storage in the pod and the process. So how do you define the process that you're running? Well, that's a pod, which maps to a container. How do you describe the storage that that pod needs? Well, that's a persistent volume claim. How do you actually represent the allocated storage? That's a persistent volume. These are all representations of resources in the Kubernetes model. Kubernetes maps these to the underlying infrastructure. So if you look at what Kubernetes actually does when it deploys these definitions, it makes you take these definitions, you push them into Kubernetes, Kubernetes will look at them, and then it will make the underlying infrastructure mirror what you have asked for. And so in this particular case, it will map to a host running somewhere on a VM in Amazon and talking to some block storage supplied by Amazon EBS. So that's Kubernetes. And it turns out because of this, this ability to manage distributed applications, Kubernetes is actually a really good platform for databases. It wasn't always that way because, well, for a long time, Kubernetes didn't have the storage management was kind of cumbersome and the management of stateful applications was cumbersome, but those are things that have been dealt with years ago. So, so what we find is an increasing number of people want to run databases on Kubernetes. The problem is that if you run them on Kubernetes, it's another place that you have to protect because if you have data, there are always people who want to get into it, especially if it's valuable data. So when you start to look at security, you usually think in terms of some kind of threat model. So what are the components of the system? How can they be attacked? In other words, what are the API surfaces that are presented that an attacker could take, could take advantage of and grab your data from? And when you put together databases, which are already non-trivial applications, with Kubernetes, which is a non-trivial system for managing distributed applications, and then include the underlying infrastructure, things like EBS volumes, things like backups, stored in object storage, you have a very complex system. And it's really kind of hard to decide, hey, where do I even start to begin to protect this stuff? So one of the key things we want to do when we're thinking about protecting data is come up with a model for thinking about layers of protection in a way that makes it actually achievable that you can protect one thing, move to another thing, move to another thing. So that's what we're going to do. And in fact, when you're thinking about protecting databases in general and ClickHouse in particular, we can think of this as having three levels. So the first is let's protect the database itself. Let's do everything we can within the scope of the deployed database to protect things, to protect connections, protect data, so on and so forth. The second thing is because the database is running inside Kubernetes, we need to think of that as something as a wall, a barrier, and we need to protect access to Kubernetes itself. And then finally, we need to protect something else, which is external data. So in cloud environments in particular, it's very common for databases to either generate or use data which is outside of Kubernetes itself. So we also have to think of that in the threat model and consider how we might protect that data as well. One thing I should say here is that when you're protecting the database within Kubernetes, there's a couple of different approaches. One is you can just go, you can just do, go full Monty and protect everything within the database, so connection between every single component. This is a typical approach in very high security environments where you don't really trust Kubernetes itself. Another approach is you actually assume that, hey, Kubernetes is reasonably well protected, so some of the things that happen within the database, like communications between individual database servers that are not visible from the outside or not routable, we can assume that those are reasonably protected and we don't need to secure those connections. So people make different choices about this, and they're both appropriate depending on the requirements. In the webinar that we're doing here, we're going to assume you want to protect everything. We'll show you how to do that, and then you can relax things as appropriate. Okay, so let's dig in and take this model, because this is a vast simplification of what of the model I showed on the previous page, and let's start using that to attack security and basically protect things. So first problem is we made the problem smaller, but ClickHouse is complicated. Databases are complicated, but ClickHouse is an especially complicated one. So our first task is to deal with that complexity in a way that allows us to manage ClickHouse easily. And that is by using one of the premier features of managing data on Kubernetes, which is operators. So and in the case of ClickHouse, as I mentioned earlier in this talk, we have the Altinity Operator for ClickHouse, or the so-called ClickHouse Operator. And the way that it works is the operator is actually a component. It is a kind of controller, if you will, that runs inside Kubernetes, and it does two things. It has a definition for what's called a custom resource definition, which creates a new type of resources in Kubernetes that represents the database in a relatively compact way. We'll see examples of this as we go along, but you don't have to define a bunch of specific Kubernetes resources. You just fill out one YAML file and with one resource, and all the information you need is there. The other thing that the Kubernetes operator does is it processes those definitions, and it sees them, and it basically makes things match inside Kubernetes. And there's a typo here. Unfortunately, this is not correct. There's a copy paste error here. It should say a ClickHouse pod talking to a persistent volume. So that's basically what the operator does. Now, if it were just single ClickHouse servers, that wouldn't be a big deal, but actual real databases are much more complicated, and we'll see an example of that in a second. What's the operator doing in the background? So the operator lives, it runs as a container, and so you can see it in the running in your namespace in Kubernetes. And every time a custom resource definition for a ClickHouse what's called a ClickHouse installation resource is applied to Kubernetes, Kubernetes will go ahead and post a change event into the operator, which will then see that definition and have a chance to do what's called reconciliation. And basically what it will do is it's going to look at the resources that ClickHouse definition maps to, and it's going to, if they are different from what the latest version of the ClickHouse installation says, it will make those resources match. It will just make changes to them, and then Kubernetes in due time will map those to the appropriate infrastructure. This process, again, is called reconciliation, and it basically is how the operator maps that the definition of ClickHouse into the state on Kubernetes. So this can be extremely helpful because actual deployments of ClickHouse are quite complex. So what you'll end up with is with a very simple definition of ClickHouse with no storage. You can do this, just ephemeral storage just to play around. You can do it in a few lines of YAML. A real ClickHouse definition might be, say 24 inches of YAML, where you're talking about different things like availability, a bunch of security features, as we'll show you shortly. And then what the operator does, it reads all of that and then actually maps it to a fully replicated shard at ClickHouse. So this is one of the biggest ways that you can start to attack security, because not only do the operators make things more organized, but the ClickHouse operator in particular has features that are built in to help you with security. Here's an example of one of these ClickHouse installation ClickHouse installation resources. So we see actually an interesting copy paste error here. We see the specification, which says, hey, we're talking about clusters. We're going to have a cluster definition. It's going to be called default. We're going to have a user defined on that, and that is the default ClickHouse user. And in fact, one of the nice features that the operator has is the ability to set a password for the default user. Very easy to do just by a single line. You can, this is a SHA-256 encoded password, which you can put in there, and now your default user is protected. other things that you can do. The default user will the ClickHouse operator knows about the default user. It will automatically restrict it to localhost as well as those IPs that belong to the cluster. So it can't be used from outside the cluster to break in. There are also other types of features related to intercluster communications. For example, when we authorize between ClickHouse hosts, for example, to do distributed queries, we can use what's called a secret to, which is basically a shared string or shared secret between ClickHouse servers, which will allow them to communicate with each other and then execute the distributed queries seamlessly and using the original counts that that started the query. So that's a super useful feature. If you're familiar with sharding and replication in ClickHouse, you probably know about this feature. So these are things that if you use the operator, you don't have to do anything special beyond setting a small amount of YAML, and you get these features essentially for free. So there's more to it than that. So we want to dig a little bit more deeply on credentials, because credentials are, obviously anything that allows you to reach systems, including ClickHouse. And we want to look more carefully at the information that we're passing around to make sure that it's fully protected. So let's go ahead and look at this in more detail. We will start with just a simple example of ClickHouse running in Kubernetes, and it might be talking to Kafka because it might be reading events off an event queue. So we're reading from a Kafka topic, so we're going to need credentials to get to that. Maybe we're using the Kafka table engine. We might be talking to other databases because we might be doing distributed queries. We've already talked about that a bit. We also could be talking to object storage, in which case we need to be very very thoughtful about how we get credentials to that and don't share them, because the object storage is outside and it's actually visible to anyone. So if those fall into the wrong hands, it means your object storage is exposed. And finally, we need to think about the passwords for the database logins. These are also sensitive, and having them floating around in unencrypted objects in Kubernetes is not secure. So the basic technique that we I just got a weird switch. Can somebody confirm that the audio is okay? My Windows is just misbehaving here.
Confirming, Robert, we can hear you.
Okay, great. Yeah, the Windows audio driver made a funny switch. Okay, great. So Kubernetes has a very well-defined feature called secrets, and they are used to solve exactly this problem of passing credentials safely into pods. We can use these in the ClickHouse operator. So here's an example of a secret. It's a kind of resource in ClickHouse, and it's super easy to create. They're one of the simplest ones. So it's called, the resource type is secret. You give it a name, and then you can pass the data in. This is basically a key root login. And then what follows after that is, in this particular case, a base 64 encoded value. So when you load this up, this is actually going to be stored securely inside etcd. We'll talk about that, and that's the database that maintains the record of resources. But this allows you then to pass it into, by various methods, to pass it into the running pod. Let's talk about a couple of those. So one of the things that you can do is the Altinity operator understands secrets, particularly using secrets for setting password names. So we have some special syntax which you can use, that if you want to, for example, set the default password, you can use this special syntax that's highlighted in red that says, hey, for the SHA-256 value, which is, sort of encoded, but you want to pass it in without exposing it, you can tell it, go to the secret called db passwords and go look up the value of the key root login. And that passes it in. So that's a really simple way to pass the secret in. Doesn't require you to do anything special. Now, there are other types of credentials that you might want to pass in. And a really common one is to pass in credentials to access S3 storage, or the equivalent on other clouds, for example, Google Cloud Storage. So in that case, you're going to pass, like a common way to pass these values in S3, or when using S3 in a pod, is to use the environmental variables. So what we can do in this case is basically pass them in using a secret, and this example shows you the syntax to pass in environmental variables. And what will happen is those will be materialized in the environmental in the environment of the running pod, and we'll be able to pick up the credentials and talk to S3. So this is a very common approach to allow people easy access to Amazon S3. So those are a couple of examples of applying secrets. We're going to show another one in a minute, but let's first introduce the next topic. So we've looked at operators. They organize, collapse things into a single, easy to understand, or relatively easy to understand resource. We've looked at secrets as a way of moving things around. Let's now talk about protecting connections to the database. And by protecting that, we don't just mean having a password on the connection, we actually mean encrypting it. So TLS is the standard for encrypting data on connections to and from databases. So there's a number of ways that this can be used, but for example, you have the client application connecting to the database pod, in this case ClickHouse, and then those pods may talk to each other, for example, to do replication or to execute distributed queries. So as most people are familiar, this is to set up a TLS connection, you need to pass in what's called a certificate. That's a document that contains a public key and a matching private key. This is used to set up the TLS connections, and is going to be required for any ClickHouse server and client application for that matter, or may possibly for client applications that want to use TLS. There's also another document that you may need to pass in, and in fact, in the examples I'm giving, I will be doing this, and that's the certificate authority certificate. And the reason for this is you may choose to, you can of course use publicly, like a public certificate authority for your certificates, but a lot of times in enterprise environments, it's just a lot simpler to create your own certificate authority and then use that to generate your server, to sign your server certificates and pass them into the servers. In that case, you're going to have to let the server know about the certificate authority certificate. Otherwise, it won't recognize, it won't be able to verify the certificates. So you'll need to pass that in, and I'll show you an example of how to do that. So the first thing we want to do is configuring the ports. So there's a couple of very simple settings that we can use. This secure yes, that just tells ClickHouse, hey, we're going to be using TLS encrypted ports. There's a settings clause that allow us to specifically say what we want to use. So in this case, we're going to enable the TCP secure port and HTTPS port. These must be correctly enabled. We're going to leave the TCP port open because it's just going to be used for localhost access. So, but it won't be exposed. We can set things up so it won't be exposed outside. And then one of the other things that we're going to need to do to set this up is we are going to have to include what's called an OpenSSL configuration. This is a tag in the config.xml file for any ClickHouse server that gives the details of where is the server certificate, where is the server key, what do I, what level of verification do I want to use, where's my server or my certificate authority certificate, where do I get that, so on and so forth. Left that out, but it's pretty easy to find out. So that gives you the OpenSSL settings. We'll do one other thing, which is we need to actually pass in the certificates themselves. And for that, these certificates are actually files, and it turns out this is a third thing that you can do with certificates, or excuse me, with secrets in Kubernetes. You can actually pass in files. This is an incredibly useful feature. So this is an example of we've created a secret that contains the server.crt, the server.key file. There's also a ca.crt file that's included here, which I didn't have space to show. And then within the pod definition, what we're looking at here is the spec for the pod definition. We now have the volume mounts. That we first of all say, hey, take this server certs secret and make all those files, manifest them as files that are mounted on a within the pod, and then we go ahead and actually make those values available. We map them to specific files inside that. You can see how we're doing that with the volume mounts. It looks a little bit complicated, but it works. So once you set it up, it's very simple. Normally, the most you're going to pass in is 3 files, so it's really not very hard to do at all. So that is a super useful feature, and in fact, I think this. I'm going to show you some of this stuff I'm showing you to you in pieces. I'm going to dive over and look at this real quickly, but let's talk about protecting your stored data first, because we've looked at operators. We looked at a couple different ways to use secrets. First of all, for passwords, but also for things like server certificates and keys. So let's first cover that. And before we get into storage, it's helpful to know how Kubernetes makes storage. So what happens inside Kubernetes is when you create a pod, and when that pod has a persistent volume claim, well, technically the persistent volume claim is for a stateful set, but the pod uses it. And that persistent volume claim is going to ask for a certain amount of storage. And the way that gets actually created, and at which point the persistent volume will be created within Kubernetes to represent the allocated storage, there's a thing called a storage class. So, and you can define storage classes, and storage classes are connected to provisioners, which in this particular case, we're going to have a storage class, we have multiple storage classes, and they allocate storage to match the persistent volume claims and do it in EBS. So all you have to do is create the PVC, and then the storage class can grab it and actually, create the PVC or PV, and then put the relevant details into it. So the cool thing about storage classes is that you may have a default one already created when you arrive in Kubernetes. You can make your own really easily. And on cloud storage, it is very easy to, most of the cloud storage provisioners support encrypted storage. So for EBS, one of the things you want to do almost by default is to go ahead and create your own storage class. And if you're using, for example, the EBS provisioner, this is how I set it up. I'm going to say encrypted is true, which means that any storage that's going to be allocated in EBS will be encrypted. Amazon takes care of managing the keys. We don't have to worry about it. But if somebody happened to see that storage through another way, they would just see garbage. So this is a really easy way to encrypt, to protect the storage from outsiders, and it has very little cost. We find it makes relatively little difference in ClickHouse performance. So to actually apply this, it's incredibly easy. All you do is ClickHouse, the ClickHouse operator, the CRD that it defines, has what's called a volume claim template, which is where you fill out what you'd like for storage. You say how big it is, and all you have to do is refer to this storage class that you've just created, and that's it. So really, one word gets you encrypted storage. This is so easy that you should just always do it. So at this point, it's good to just jump over and have a quick look at how things work under the covers. So here, so I'm out on a jump host. Let's clean things out a little bit. And I'm looking at a samples directory. I'll give you the URL for this, but all the code that we're using here comes from samples that I've developed for various talks. I'll give you the links at the end of this. But let's just go and look at one of these, the actual definition. This is a ClickHouse installation resource, and what we're looking at is the definition of the cluster. For example, we have 2 replicas, 1 shard. Here's the settings to get my ports set correctly. Here's the connection to Zookeeper. By the way, you can encrypt the connection to Zookeeper as well. That's I didn't do it in this case. Here's an example of setting the passwords using a secret. Here's an example of passing in a file which shows the which contains the OpenSSL settings. This is actually, I have to say, ClickHouse does this extremely well. This is these are settings that are supported by the underlying C++ libraries that we use for SSL, and you can see that all our locations of things are correctly specified. These are pretty easy to set up. It takes a few minutes, and then here we can see the pod definition where we're mounting our CA certificate, the server certificate, and the server key. And then right down here, there's our encrypted storage. So I showed you that all in pieces. This is what it actually looks like. And then when you actually see the servers, let's do a kubectl, which allows us to look at what's going on in our namespace. We say get pods. Oops. Oh, okay. It looks like I'm not authorized. I will need to actually, let me do let's just see if I can get authorized here. Looks like I've got an expired token. We'll skip that part of the demo, but take my word for it. This server is set up, it is working, and all of the it has all the connections that we just described. One of the things that also is here, which I want to emphasize, is we're using Argo CD, and let's see if we can get Argo CD to, because we're going to talk about that in a minute. This is an incredibly helpful tool. Argo CD, as we'll see in just a minute, allows you to map definitions of different types of components inside services in Kubernetes to keep them in GitHub and then map them or basically map them and install them in Kubernetes clusters. So in fact, the ClickHouse operator that we're using is installed from Argo CD, and the ClickHouse Zookeeper that we're using for this cluster that I created is also in Argo CD. So we'll have a quick look at that in just a minute and explain how that works. But this is something where I just want to do a, sort of show you this because it's incredibly helpful for setting these services up. So let's in fact go talk about that. And so we'll go back to the slideshow. So one of the things that I've stressed in this talk is that to do security effectively, you need to be consistent, and you need to put things, just as the operator helps you organize the ClickHouse service, you want a way that will allow you to organize all the services that you're using. And the ideal would be to have the definitions of these in GitHub and be able to apply them to a particular Kubernetes cluster. And what that does is that this is obviously GitOps, where you basically are storing the definition of your services. And then if you need to make a change, what you'll do is you'll actually just commit something to GitHub. And then what you'd ideally like to do is have it then be applied to the Kubernetes cluster. And this keeps your definition well-defined and gives you an easy way to sync it to what happens out in the real world. So this is in fact exactly the problem that Argo CD solves. There are other ways to do this. Another really popular way of managing services on Kubernetes is to use Terraform. So in if we look at the Altinity customers, for example, I think something like maybe 1/3 of them, or at least 1/3 of the people I've talked to, use Argo CD. The other 2/3, maybe a little less, use Kubernetes. And then the final contender is the Ansible. There are a bunch of, we actually use Ansible ourselves in some cases. But what Argo CD does is it allows you to point to what are called applications, which can be Kubernetes manifests, so just a resource file. That's the way that you can install, for example, a ClickHouse server. They could be customized, which are customized projects. Customize is a a cloud native computing foundation project that allows you to take manifests and tweak them as they're installed. So Argo CD understands those. And then finally Helm charts, which are an incredibly popular way to deploy applications on Kubernetes. And what's cool about Argo CD is it supports all of them. And regardless of how they're actually defined, you can use the same commands to set them up. And what it will do is then give you the means to take these and then apply them to specific clusters. So how does it work? Well, basically, what you'll do is you will store your definition of your application, including all the services, as a set of sort of as a set of application definitions and Helm chart definitions out in GitHub. So you'll make a project and then you'll push it up using Git. Then you'll also need to install Argo CD, which is fairly simple. It can be done in a few minutes. It will live in one of the namespaces. Typically, it wants to live in the Argo CD namespace. And then once that's set up, you can use the Argo CD command line client to define applications. And what that does is you tell Argo CD, hey, I've got an application. It's located, at some URL in GitHub. And then you can sync it, which means, take what's there in, take what you see in GitHub and go ahead and apply it to either a local cluster or some remote cluster, and then Argo CD takes care of the installation itself. This process is really great. We've done separate talks on it, which you can refer to. It's addictive once you get using it, because the thing is, it just keeps track of all your stuff's in GitHub, so you never lose track of where your scripts are. So this is incredibly helpful to use, to help with security just by organizing you. There are a couple problems that come up, and one in particular is how to handle credentials. Because if you just pass if you just store, for example, Amazon secret keys in GitHub, I don't know if anybody on this call has done this, but if you do, you will get an email from Amazon literally within minutes saying, hey, we saw what you did. You just checked in an Oz secret key. And if you think you can base 64 encode it, I think they know about you as well. So what'll happen is, the problem we have here is that if you're going to be putting in the secrets, which may be necessary to make the system work, as we showed, you need to have a way to actually process those secrets so they won't become visible in GitHub. There are several ways of doing this, but one simple way, which is called sealed secrets. This is a project called KubeSeal. What it does is gives you the ability to encrypt the secret before you check it into GitHub, in which case the values just look like junk, and Amazon won't be, or whoever your cloud provider is, or your external application is looking for this thing, it won't be concerned that you're checking in a live key. And then the way that the seal secrets work is when they're put into to Kubernetes, you can install something called a sealed secret controller, and it basically looks for these special resources, and then it decodes them inside Kubernetes, and so that the secret becomes visible and usable by your applications. Another way to do this, which is very popular, is to use products like Vault from HashiCorp. And there are ways beyond that, but this is something when you're using GitOps, it is something you then have to take care of, because since you're checking in code, it may be publicly visible. You need to make sure secrets are protected. Speaking of GitOps and applications and things, another thing that we should think about is scanning containers. Now, in the case of ClickHouse, if you're running, for example, one of the ClickHouse official builds from ClickHouse Incorporated, or you're running a stable build from Altinity, we scan these things. We're all kind of, so for example, we run Trivy and Docker Scout on all of our builds. They're both great. Trivy is excellent. It's like the easiest one to use. It works command line, and you can scan any container you want. I recommend doing it. So anything that, for example, if we scan a ClickHouse container and we get a CVE marked high, we're going to stop the presses, find out what's going on, fix it, and then and rebuild. Docker Scout is a product provided by Docker. It's currently free, but it will scan things that are in Docker repos, for example, in Docker Hub. So these are great products that you can use that are available for free, and you should definitely check them out. So we're kind of approaching the end of the security talk, because we've really focused on the most complicated part of this, which is understanding how to protect the database. But and we've seen a number of ways to do this, which are all kind of common sense and kind of layer on top of each other. But now we need to look outside the database. And here's the threat model again. So we're protecting the database. We've just spent about 20 plus slides doing that. Now what we want to think about is, let's protect Kubernetes followed by external data. So protecting Kubernetes, we can do that in, if you need to describe how to do that in 2 words or less, it's managed Kubernetes. This is the simplest way to get, to get up the, to protect things as quickly as possible. The reason for it is that the managed Kubernetes will do things like ensure, for example, etcd has encryption enabled, that it doesn't go down, that you're basically, there are checks on the workers, so on and so forth, that they get, for example, updated when when there's a security problem, or if there's a Kubernetes security patch that needs to be enabled. That can be, in fact, if you're running on Google, they will just, if you're not careful, they'll just apply it like whenever they want. But the point is that you'll remain secure. This is a really great feature. They're super cheap. It turns out that if you look at Amazon EKS, Google GKE, Azure AKS, they all clock in at 10 cents an hour to run that's the cost to run managed Kubernetes. It's a total deal. You should always do it. And most of our users, in fact, do. Very few of them run Kubernetes themselves unless they're on-prem. So if you have managed Kubernetes, of course, you're going to do some obvious things like, hey, you've got Kubernetes, you've got credentials to connect to it. We use short-lived keys. In fact, I showed you an example of that in the demo. I couldn't log in because I had botched copying in my my short-lived key to. We shut off SSH to Kubernetes workers. There's really no reason to, go there. You want to set up the networks. This is easier or harder depending on which vendor you're using. For example, use private subnets, use VPC peering so that there's no public endpoints. And then there are very good vendor scanning tools. I want to highlight Amazon GuardDuty. It's excellent. It's very straightforward, very low cost to run, and it's not, none of these is a panacea, but hey, if somebody's doing something weird in your Kubernetes, inside of VM, Kubernetes is using Oz GuardDuty, will typically send you a message and you can go look at it. So then the final thing is external data, and this is, of course, so broad that we, really, you really need to use common sense. But 3 kinds of external data that are very common with ClickHouse are database logs, object storage for table data, and then backups. Let's take them in reverse order. So backups, for example, you could use ClickHouse Backup. You want to, you can supply it with keys, using there's various ways to supply it. You can use the techniques that I showed I showed above to enable it to get the credentials, but you definitely want to have encryption enabled when you upload it. You also want to protect the object storage itself through appropriate storage policies, so that, for example, not allowing public access to S3. If people can get your backups, of course, they don't really need to even bother with Kubernetes because they have all your data. So this is something you really need to protect. Second thing, you can store ClickHouse tables on S3. There are a couple different ways to do this, but the S3 back merge tree is increasingly popular. And so again, ensuring that the object storage outside is protected is job one, because yeah, if somebody can get that, then well, they don't need to visit ClickHouse because they can already see your tables. And then finally, database logs. This is one that people don't always think about. But if you're using any kind of, for example, if you're using Datadog and collecting logs there, or you are using Grafana Cloud, what that means is you're taking log messages out of ClickHouse and forwarding them, for example, to Loki in some other Grafana Loki in some other location, there could be sensitive information in there. So it is possible to put filters on top of in ClickHouse to define regex expressions that will allow you to suppress certain types of logs. That's something you should definitely consider. For example, to prevent things like personally identifiable information from weaseling out. Or just don't export it. I mean, that's another thing. You might want to just keep that inside, keep those logs inside Kubernetes and go visit them there. So just in general, if you're, running cloud native ClickHouse, in summary, there's a bunch of things that we've introduced, and here's the list if you want to sleep well. It's not complete. I mean, there are more things that you can do, but we've covered some of the really important tools, ranging from operators to manage Kubernetes, and then beyond that, common sense. You can't protect against every attack. There's just no way to do it. One kind of attack that's particularly hard to protect against is just bugs in your own stuff or something that you use, which may expose windows that you don't understand. This, I would say, is actually an implicit reason why you want to use GitOps. GitOps allows you to deploy new versions of your services relatively quickly. So when you do find an exploit or hear about it, you can actually update your software. Beyond that, it's common sense. Because this problem is hard, it's tempting to say, oh, we're not going to attack it. But there's just so many easy things that you can do. And I've shown you many of them. You can just apply those. So, of course, you might not want to do that. And you could just save some effort by using Altinity Cloud. Most of the stuff that we talk about here are things that we developed working with Altinity Cloud. We use them ourselves, so save some effort. Altinity Cloud can run both in your own Kubernetes as well as in our Kubernetes that we run in our accounts. You can take your pick. This is an example, actually, and you can't tell the difference. You get the same UI, you get the same API access. Either way, we take care of managing the database for you. So it's not just security, but many other things besides. And in fact, the Altinity.cloud, just to hammer this home, we can basically manage ClickHouse anywhere. We run it in our own accounts on EKS and GKE. Azure is on the way. Or we can run it in your account, in which case all we need is some Kubernetes. And in fact, we have people running this. We have people on Azure using this. That's quite recent, as well as and are working even on with on-prem customers on this. So lots of options if you want to go that way. You may just want to run it yourself, and in that case, lots of information to help you do that. So the ClickHouse Operator has all of these are open. So these are 3 open source projects you can consult. The ClickHouse Operator be the first stop. In particular, the examples of how to configure the ClickHouse Operator, I did that using what's called the security hardening guide within the operator. It's in the docs directory. This has a bunch of tips on how to set things up. Try them out. Next thing, if you want to see worked examples, there are examples within the operator, but I have specific ones related to this talk. Oops, wrong. It looks like I got some typos here today. There is, I'll fix this in the slides that are sent out, but it's ClickHouse SQL examples. And finally, the Argo CD project. As I said, this is kind of addictive once you start using it. You will actually, because it allows you to set these things up very quickly. So for example, when I install the operator, I no longer go to the operator directory. I just ask Argo CD to do it for me. And then there's Altinity documentation and a wide range of Kubernetes docs that can help you understand security features, like learn more about things like secrets, for example. And that's it. So I hope this has been helpful. I'd like to thank you for listening and wish you good luck. If you have any questions, I'll stay around for a few minutes and I'd be happy to answer them. So feel free to queue them up if you've got anything. So I'll give you a minute or two to think about things. Okay, got kind of a quiet crowd here today, so give you one more minute to post anything. If you're thinking of something, just post it into chat or and we'll jump in and answer. Okay, looks like don't have any questions coming up today. So once again, you will get a link to the slides as well as a recording that's going to come out in within 24 hours. Thank you so much for attending today, and thank you, Kiara from marketing, for helping to set this up. And good luck. If you have the contact information is here, you can always come check in with us if you'd like to learn more about security. This is a topic that interests us, and we love to help people. So thank you very much and have a great day.